A Softek IT Consult.
We are praying. Okay. So, Father, in the name of Jesus, Father Lord, we bless you. We thank you. We magnify your name. We heal you. Into your hands we commit our bodies, our souls, and our spirit. We ask you to come and take control over our class. This evening we've come before your presence. We ask that you become master and you become Lord over everything that we do in here. We ask for wisdom. We ask for knowledge. We ask for understanding. Help us hold our hands in this journey. In Jesus' name we pray with thanksgiving. Amen. Okay, so we've come to what? This lecture. This is programming with C++. Yes, programming with C++. All right. Yeah, so we'll be taking an overview of C++ programming language. And these are going to be our objectives. It's very, very important that we always achieve or attain our objectives at the end of every lecture chapter. Okay, so we are going to look at the introduction of C++, why we should use C++, the difference between C and C++, object-oriented concept of C++, and then we're going to learn standard library component like input-output stream. Yes, so these are going to be our objectives. So let's dive into it. And these are, okay, objectives, still some more here. We are going to understand the C++ program development, process flow, difference between process and threads, and then we are going to explore C++ programming in Codeblocks, but we will be using the C Lion, the IDE I use in here. And then so let's dive into this. Yeah, I'm going to take my time because we need a quality lecture in here, okay, to explain everything in this particular lectures. Okay, so this one says C++ is a programming language created by Jan Strausstrup in 1979. It was formerly called C with classes, right? That is because you had C, C++, right? So C came first before C++ came, and then it's followed with with C#. It's followed with VB. It followed with Java, and then they were going. So it tells us that the first one which came would automatically difficult than the next one that follows. So automatically C becomes difficult than C++ because, okay, since C was a mother, C++ will be maybe a daughter or a son. So they'll try to make those things that are difficult in C easy in C++. But yes, still C++ is still one of the most difficult languages to learn as program. But it is good because it gives you the good fundamentals or a strong hands when it comes to programming. Whoever understands C++ always understands almost all programming languages. Yes, because C++ is like a manual car. You have to do everything by yourself. Yeah. But when you take languages like Java and Python, it is like automatic car. You just have to do this and then it starts moving. So when you learn it this way, yes, it gives you a strong foundations of programming. So it was being founded in 1979 by Jan Strausstrup. So C++ was coined by Rick Muschitti in 1983. It was commercially released in 1985. And then C++ evolved from C, as we said right from here. So in here, in the mid-1998, the ANSI or ISO, Institute of Standardization Organization, okay, they actually yes, in the they actually approved it as a programming language, okay, because the ISO is an organization who, whenever you bring a product, either it's being electronic, either it's being a system, if you want it to go internationally and then worldwide, they have to check and then see whether it meets their standard. If it meets their standard, then meaning it can be worldly or internationally recognized. Yes. So you can tell that maybe some television, maybe like Samsung and those kind of product that comes, yes, they have to go through the Institute of Standardization, an organization of standardization, that is ISOs. So that was how C++ actually came by. So why should we use C++? C++ is used in every computing system. It is efficient and then it is close to the machine programming. So this is why I'm saying C++ is difficult, because it is it is closer to the machine language. Machine language, okay, in this particular ways, we have one that we call what's the name? Assembly language. Okay, then we have one that we call what? The machine language. So assembly language is what? Is also what? Is after assembly language, you go to the machine language. So the machine language is the ones that we write in what? In binaries, like 0101, as you know. So assembly language will be having something like maybe, like we write push, like we write what? We write add, like we write what? Remove. Those are assembly language, but they have some codes that you have, right? You have pop and then things. Okay, yes, even though it is it's sometimes difficult to write. It's difficult to write because you have to let the brain be working, like, very, 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 very courteous when writing. Because it deals with what? Memory directly. Now, when we take C++ programming language, we say it is a high level programming language, which means that human beings can be able to read and understand. So when I say something like, the language we are speaking, it is a high level language that everybody should be able to understand. When I say machine language, only machines should be able to understand. So C++ is actually in every system. The laptops that we use, the computers, the remotes, everything it has for C++. Majority of the systems have C, even cars, they have C++ in them. Okay, we use them in what? Embedded what? Systems. So C++ is what? Is efficient. Okay. When we say efficient, it means that C++ is one of the, let me say it is the most fastest programming language. Like when you use C++ to write what? A code or build something, that particular thing that you build is very fast, is very efficient. You can't compare any programming language, the speed, any programming language to C++. I heard they brought something they call Rust or Roost. But I haven't checked it out. But yes, the C++ is the most efficient, is the most fastest programming language that we've ever experienced for the past, let me say, 15, 20 years. Yeah, so when we say it is efficient, it is the most fastest. Okay, I'm explaining all of these concepts because you may be meeting them in section A. And then C++ has object-oriented programming. Okay, so when they ask you, is C++ object-oriented programming? The answer can be debatable. That it can be yes, it can be no. That's what I'm saying. That is that C++ is not a pure object-oriented programming language. In that, it's actually borrowed. It actually what? It actually borrowed the object-oriented concept. Okay, from what's the name? It's borrowed from either Visual Basic or C#. Okay, yes, it borrowed from them. Because C++ was just procedural. When I talk about procedural, I mean that the codes are being written in line by line like this. Okay, yes, and it executes line by line by line by line. But if I talk about object-oriented programming language, okay, we write them in composite, like one particular form has a lot of code in here. Maybe this can be a car. So this is the brake of the car. And then the same car has maybe the steering. The steering is here. The same car has maybe the tires as here. So all of these are in one particular container. Okay, that particular container is an object. That is why we say object-oriented programming. Okay, so this one says C++ is a compiled language. Yes. So when they ask you why is C++ efficient and faster, say that C++ is a compiled language. The reason I'm saying that is that C++ actually compiles the whole code. Every code that you've written, it compiles the whole code as one time, and then it runs it immediately. But when we take a language which we call interpreted language, like Python doesn't compile the code into one. It's it interprets the line 1, 2, 3, 4, 5. But C++ actually takes all of them as one at one time, and then it runs. So just imagine Python doing 1, 2, 3. By the time C++ finish 1 second, Python is going to use maybe like 50 lines or 50 seconds to complete. So when we say compiled language, okay, that is what it means. So C++ is a compiled language, which makes it faster and efficient. And then C++ is universally usable, okay, and then it is portable, okay, for various platforms. That is why we use C++. When we come to object-oriented programming, okay, it helps us to identify components called object. I actually explained this, that you write what? You write portions of code, okay, all in one particular container. After that, that particular container becomes what we call the object, because we can use the object to access these particular pieces of code that has been written in. We took a car as an example. Okay, this particular car is an object, right? In the car, we have the what? We have the light, we have the steering, we have the brake, we have the horn, we have the seat, we have the tires. All of these are what? Are parts of the what? Of the code, or their functions. They are doing something in the car. But the whole total car is what we call the object. Okay, but in programming, we say, okay, this car is a class. But at the moment when the car starts running, it becomes an object. So an object is it's an instance of a class, or a class that has been transformed. That is how it is. And then we say that what it specifies relevant data and possible operations to be performed on that data. We'll look at that when we get to object programming. Each object consists of data and operations on that data. Yes, when we say data and operations, we mean that what we have variables. Okay, we have variables, and then we have functions. So when I take the car again, okay, the variables will be, okay, I'll say color of the car is red. That is a variable. But when I say the brake is a function. Are we together? Are we together? Yes. So that is the data and the operations. And here this one says an object combines data and operations on the data into a single unit. This is what we call encapsulation. Okay, which means we are putting together the variables and then the functions all together in the same code. So we call them combining data and operation. That is encapsulation. This is part of what object-oriented programming language. Yes. So continued right here. A programming language that implements object-oriented oriented principle is called an object-oriented programming language. Learn how to represent data in computer memory, how to manipulate data, and how to implement operations. Write algorithms and implement them in a programming language. I hope you've done algorithms in discrete math.
Yeah.
Yes. So you see, algorithm is a step-by-step approach we use in solving a problem. So assuming maybe I give you, okay, so what can be the algorithm to withdraw money from the ATM? Yeah, so assuming you are being asked that question, like what is the algorithm to withdraw money from the ATM?
Okay, first of all, you have to have your ATM card.
Yes.
And also on the ATM card, you have to have your account number.
Yes.
And your PIN to be able to withdraw in case you have been asked of PIN.
Yeah, but you see, when I asked what is the algorithm, is a step-by-step approach in solving a problem. So you have to be able to tell us how you are going to be using those things to withdraw the money from the ATM. That is the algorithm. Yeah, so if I ask you, okay, how do I get to GCTU? Okay, you ask, okay, so where are you coming from? Are you coming from La Paz or Circle? And it means you have to pick car from La Paz, and then what? You tell the mate that maybe Abeka, and then yes, after Abeka, you have to see Peace FM. You have to do that is an algorithm. So as even I tell you how to withdraw money from the ATM, you have to get the ATM card, okay, and then you go to the ATM, you insert your card into the slot. After you insert, okay, you're going to enter your PIN. So you see, it is a step. And no matter what, every ATM is supposed to do the same way. Or am I lying? ATM has almost similar way in withdrawing money.
Yeah.
I don't want to put in your card, you have to enter. That is an algorithm. So maybe if I say that's what, how can I add two numbers in programming? I will say that, okay, first of all, you have to get two variables. You keep the numbers in two variables, and then you store their result in a third variable. That makes sense. That algorithm is what is correct. So if I say maybe assuming maybe in those times we used to buy scratch card like MTN, Vodafone, Tigo, and those ones, how do you reload the time on your phone? You tell me that was you have to go to the agent to buy the scratch card. When you buy the scratch card, you have to scratch the black thing on the card. You enter the number. The number crapo, we have a way of entering the number. If you don't do it that way, it won't work. You have to first dial *138*, and then you be entering something before it. So that is an algorithm. It is a step by step. It's a way of doing it. And then it is almost the way that everybody does it. That is an algorithm. So when it says that is so, in programming, they may give you some questions to solve. And because they know that's what the question has an algorithm, they're not going to worry themselves. Okay, when they ask you, okay, write this particular program, you have to know the algorithm before you can get it right. Sometimes if you don't understand the algorithm or the way that program, sometimes you may have the idea, but the whole thing is that the reason why you learn discrete mathematics is for you to understand algorithms. Okay, how do we do this? Okay, how do I okay, assuming, let me write this particular thing. Assuming I have 1, I have 2 here. Yes. I have 1 here, I have 2 here. How do you think I can replace this particular, or I can interchange this particular one, this particular putting 2 here and then putting 1 here in programming? How would you think I can be able to do this? Am I just going to move 2 to 1 and then 1 to 2? If it is that, how am I going to do that? Okay, so in doing that, this is what is going to happen. Okay, I'll have to get a third variable here, and then I'm going to put 2 inside here. Now this is now empty, right? And I'm going to move 1 inside here. Now this is also empty, right? And I'm going to move the 2 from here into here. Are we together? Yes. So come again. Okay, let me go over. As I was saying, in programming, I have 1 here, and I have I have 2 here. Okay, I'm like, how can we interchange this? You can't interchange this by sending 1 here and then bringing this 1 here. No, it's not possible to do that in programming. Good evening. Right. The way you can do this is to get a third variable here, right? And then you move 2. You move 2 here, right? Now here is empty. And then what? You move 1 inside this one. So here becomes empty. And now you move the 2 back to this. Are we together? Yeah. Yeah. So, so this is an algorithm of how to solve the particular problem. That is how we go. So algorithms are step by step. So in programming, if you want to really understand programming, you have to understand the algorithms, or you have to always know how to solve your problem. Okay, it is not always about, yes, a minute. Yeah, from dining. Yeah. Challenging. What's you? Say what's you? One chair. Oh, chair. I make me in chair. Come on. Man, basket in it. When you never never some net, never man. Hey. Good afternoon. Me my bedroom ha. She ni ha. Me ni musa baba ya mama. Me bedroom ha. She ni ha. I want him. Sister, what bra me? Sha, we be free. Oh, bana me catch on say fa ndie ma ne bra no be some net ne mama. And one no own net ni pa pa be see mama me. Wo de da ho na akọ chinchi. Peja bra me. Peja bra me.
Mr. Peta Brami, Petania Mana Brami, Major.
Aye. Menino.
Tá. Não, lá, te sabe.
Right, me too, Benata. Yeah. Yeah, good evening. Where's Shafa? Where could be? Good evening. How are you?
I'm fine.
Jabra Kamesha, how are you?
How are you?
I'm fine. What about you?
Fine.
Mm-hmm.
What's it? I'm doing fine.
I'm going to school today. So someone may code me. I say VF crack. Phone. Oh my approve on. Nada. If I could send you. Eh, okay, no abo. Sama abi, obeyamo. Hello? 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 Hello?
Yes.
Yeah, can we go on? Yeah, so sorry about that. Okay, so that is the whole thing about this programming thing. It is about what? Knowing how to go about and then what the algorithms, right? I have been asked, okay, I'll write a program to add two numbers. You should always know the algorithm. First of all, we have to get what? Two or three variables. We add two of them together and then we put one in the other one. And then that is it. So it is always about what? About knowing your algorithms, how to go by it and then how to do it. But we'll see. We'll see to it. Okay. So we have to learn how to combine data and operations on data single unit called object. C++ was designed to implement object-oriented what? What's up? Yeah. And then here, they are like what? Data encapsulation for controlled access to object data. We'll look at these ones at the last end of the class. These are the advanced C++ concepts. And I don't know why they even place it in the beginning of the lecture slide. like that. And then we have also inheritance. Okay, inheritance is like you having a mother and then inheriting something from them. So you can create what? A small car from a big car. But we'll look at that later at the end of this whole thing. Yes, we are going to look at all of these and we have also polymorphism. All of these are object-oriented programming concept. Okay, that is having multiple forms that can have varying effect during program execution. Okay, so let's look at this. This one says a C++ program. Yes, as we all know, we know that what C++ program is written just like this. And this is what you should always know, that this is how to write your C++ what sample code. This is the sample code, or this is the prototype, right? That is how every C++ program should be like. So whenever you see maybe a device that was made or written by using C++, you should know that it had this particular code in it. Without this code, the program cannot run. Yes. So it goes this way. Hashtag include IO stream. I said other time this is what input output stream, right? And then so input output stream means what we are using the input. Input means we are keying in, okay, using what our keyboard. That is the input. The output means we are showing it on the screen. So this is what a stream of characters, right? Then using namespace std, I said that the namespace, okay, is actually a standard library. It contains the keywords, okay, that we'll be using in the program. So if you fail to write this particular using names with std, you can't get this. So it means that this particular keyword is in the namespace. So if you don't use namespace, then you have to write it this way: C out like this, and then you put something like this before you can write this particular thing. But if you write using namespace std, you don't need this particular one, right? Are we together?
Yeah.
And then when you get here is a function. All of here, I told you the other time that when you see double bracket, right, it means that it is a function. So this particular function starts from here and then it ends here. So all of this is a function. It is called the main function. It is the main engine of the C++ program, right? Without it, the C++ program cannot run. So this is an integer function. I told this is every function has 4 parts. 1, 2, 3, 4. First of all, is the data type. Data type. All right. I hope you know data types.
Yeah.
Yes, and then the second part is is a name. Is a name, function name. The third part. Is what's the name? Is a parenthesis, right? The bracket. And then the fourth part is the body. And the fifth part, okay, can sometimes be the return. I'm going to explain this return. Please pay attention. Okay, the return. There is only return. Return only shows up when the function has a data type as as primitive. What do I mean by primitive data types? Primitive data types are data types that are already in the programming language, like int. Okay, those particular ones, int, char, okay, string, and then double float. Those one came with the programming language. Those are called primitive, or we say predefined data types. They came with the programming language. But we have also another one that we call void, VOID. Void, okay, it's a data type. Okay, all of these ones, this means that this is integers. 1, 2, 3, 4, 5, 6, right? This is character. It can be A, it can be B or C. This is string. It can be A, B, C together. Okay, and then it goes on and on and on. So meaning, at the moment you use a data type as of these ones, it means that the return type should be the same thing. So meaning this particular function, as you can see, it is returning 0. Why? Because it has a data type of integer. But the moment what I change it and I make it like string, meaning it is going to return a string. Maybe it can return like maybe Yakubu. It should return Yakubu as a return, right? That is going to be, so a return means the result of the function. Return means what? That is the result of that is the output of the function. Are we together?
Yeah.
Yes. So, but when we use void this way, void is not going to what? Return anything. Void is rather what? Bringing everything in the function. It is not using the return. So these are the trick to the whole thing, right? So on this particular program as well, we can see that this particular program as well, we can see that we have what? We have C out, we can see we have end line, we can see we have the insertion, and then we have the extraction operator, or let me say the output, and then the insertion, and then the output operator, right? Yes. So yes, when you see this particular one, this is the body of the function. This is what? Curly braces. So inside the curly braces, that is whatever the function is doing is written. So in here we say that C out. Okay, C out, we say we are going to print. Okay, and then we said what? Whenever anything is in the double quotation marks, that is what is going to show on our screen. So we are printing what? Enjoy yourself with C++. And then here we say end line. End line means what? Next line. Assuming maybe here writes what? Enjoy yourself with C++. We say what? After, move to the next line. Okay, so the next line is what? Is end line. That is what we have in here. And then after that, make sure you return 0. Yeah, so this is going to what? Return. It is going to print this and again return 0. Returning 0 for the main function means that the program has ended. That was a success. Are we together?
Yeah.
Yes. Okay, so let's move on. So processing a C++ program. To execute a program written in a high level language such as C++, use an editor to create a source program in C++. To execute a program written in a high level language such as C++, use an editor. What is an editor? An editor is an IDE. An IDE, as an example, as the code blocks you've been using, the C Lion that I'm using, these are what we call editors, right? So in a C++ program, statement begin with hashtag symbol. Okay, statement which begins, which I think he meant to write, which begins a statement that begin with the symbol hashtag are called preprocessor directives. Yes, that is true. So preprocessor directives is what is telling our page, okay, that's what we are putting in something. This page, okay, maybe assuming that what I have a file. Let me take this, like this particular file. Let me assume this particular file, and I save this particular file as, okay, as TST. You know, I can save this particular file as what? As .html, like this. It means that this particular file is going to be what? A web file, right? So when I say what? Hashtag also on the page, I'm telling the page that this page should be having something very important. So I say hashtag include IO stream, which means that this particular page should include what? Reading and writing. Are we together?
Yeah.
Yes. So these statements are processed by a program called preprocessor. Use the compiler to check that the program obeys the rules. Translate into machine language. This one, our compiler is going to do that for us, the translation. Because we just have to just run the program. It is going to just run it. And then this one says software development kit, that is SDK, may be used to create a program, right? So that is processing a C++ program. It's continuous in here. We have a linker. So pay attention. This one's a section A. Section A question. This is how they are. Okay. A linker combines object program with other programs provided by the software development kit to create executable code. Yes. A linker combines the object program At the moment you write your code in the file, okay, yes, it becomes what? Just what? A normal file, an object file, right? But for it to be converted into what? Executable, it needs what? A linker. So when you write a code inside this particular IDE, right, it is just what? An object code, right? Or an object file. So there is something in the middle, okay, which is going to help us to what? To convert all of these particular code that you've written into an executable. An executable is a what? Is a file that can run on the what? On your PC, okay? It can run on your PC, like the VLC program that you've been opening, Office and Word. They are all executable, which means they can execute and open and then launch. Okay, so we have a linker, okay, which does that for us. And we have what we call a loader. A loader is going to load the executable, that is the final product, okay, into what? The memory. So assuming maybe I'm creating an app in C++, I've written my code in what? In code blocks like this. And then the codes are what? Are all inside like this. After that, I've saved it and I've converted it into what? Executable. Now I have the icon here like this, nice like this. So I use the what? The linker. I use the what? The linker to what? To create the executable. I use it to convert my what? My lines of code into executable. And now fine, as I've done that, I have what? Executable which can be what? Be run on what? On computers, right? Like normal what? Applications. And then here we say we have what we call a loader. A loader is a what? It's a tool, okay? Or it's anything that can what? Load the executable. It can load the executable file into what? Into main memory. Okay, the last step is to execute. I hope you are following.
Yeah, I'm following.
Okay, so this is the steps. Maybe they can also ask you, write the steps to what? To running a C++ program, right? You know that's what step 1 should get what? An editor or maybe an IDE. 2, preprocessor. Okay, and then 3, it has to what? Go through the compiler, and then 4, linker, loader, execution. So I'm going to explain this again. The editor is a what? Is a program that you write your C++ code. The preprocessor, okay, is telling the page that we are including certain features or certain what? Libraries on that particular page. Compiler is a tool, okay, that is going to what? Compile our old code and translate it or convert it into machine code. Okay, like 0101 or maybe assembly or any of them. Are we together? All right.
Yeah.
And then the linker is what? Is going to convert our what? Our object code into executable. And then our loader is going to load the executable into memory. After that, we can what? Execute. Okay. So that is fine. So compiling and linking, right? Compiling and linking. You run the code through compiler. I've explained this. If compiler generates errors, look at code and remove the errors. Run code again through compiler. If there are no syntax errors, compiler regenerates equivalent machine code. And then linker links machine code with what? With system resources. Okay, I think this one is for self-explanatory. Here the loader and execution. Once compiled and linked, I think they are explaining what I have explained right here. Right. Once compiled and linked, loader can place the program into the main memory for execution. The final step is to execute the program. Compiler guarantees that the program follows the rules of the language. Okay, that's not what guarantee that the program will run actually correctly, but it's just following the procedure or the algorithm that has been set in there for programs to be loaded into memory. A process is a program loaded in memory. Okay, so I'll say this: a program is a what? It's a running process in memory. A process is a what? It's a running program in memory. So assuming what we are doing right now, we are running a program called Adobe Reader. So that Adobe Reader is running as I'm talking to you. So it is called a process. So any program running in the memory right now is called a process. So process is a program loaded into memory along with all the resources needed by the program. each running instance of a program is a process, right? Each running instance of a program is a process. Each process runs independently, right? Each process runs independently. That is true. Okay. And then we have a thread. Okay. A thread. When we talk about thread, okay, assuming that I have this particular program in here, right? This particular program, I say that when you click here, when you click here, okay, when you click here, it turns on 1 bulb. When you click here, 2 bulb. When you click here, 3 bulbs, right? Okay. And then all of these things, okay, they are functional in the program, right? So me having these things are going to be called thread, right? They are all doing something. They are all performing a particular function, right? But the moment I can be able to run all of these 3 things together, I'm doing what we call multi-threading, right? Running the 3 of them together. But if I run one, that is it. It's a thread. Like it's within a process, right? So when you find a program, okay, whatever is in the program, like the functions in the program, what the program is doing, what a single one of them is called a thread. I hope you get, because when you go and learn operating system, you learn this particular same thing in it too. Yeah, so ask you what is a thread. So a thread is a what? Is a unit of execution within what? Or it is a what? It is a running function within a process, right? Yes. Or it is it is a process within maybe a program. Same basic definition. So a thread is is a unit of execution within a process. A thread is a unit of execution within a process. Multiple threads can be initiated from what? A single process. Yes. So there are single threaded processes and multi-threaded processes. Yes. So that is it. So like the WhatsApp applications that we use like this, they are multi-threaded, because you can do multiple things at the same time on the application. You are watching status, you are doing this, you are doing this, you are doing that, you are doing this on the same application. Application is not even doing one thing, it is doing multiple things, okay, all of the while. Okay, so yes, so as you can see, that is what a basic unit of execution. Okay, as I said, a thread is a unit of execution within a process. So we have multiple threads, multi-thread. Okay, these are triple units of execution in the same application. That is a thread. So threads and processes in programming. The program starts out as a test file of programming code, as you know, because we create a file. The program is compiled or interpreted into binary form. Okay, the program is compiled or interpreted into binary form. All right, binary is 0101. As I said, if the compiler is a program, or compiler is a tool which translates or converts your high level programming language like the C++, C out, blah 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 written in there into machine code. Binary is 0101. So compiler does that particular thing. So the program is compiled or interpreted into binary form by the compiler, right? And then the program is loaded into memory. So here you are seeing that we are having the loader. Loader is here, and then the linker is also right somewhere here. Okay, so the program becomes one or more running processes. Processes are typically independent of one another. Threads exist as a subset of a process, and then threads can communicate with each other more easily than processes can. So it is saying that, okay, in the program that you have written it in a way that, okay, the program can be running 3 things at the same time, meaning it is doing multi-threading, okay? Or maybe the program is having a time counter. It is reading the time in the program. That same program, okay, is allowing people to send message. That same program is allowing people to do calls, meaning we have multiple processes running in the same program. That is threading, and then that is a process. Okay, so programming with C++, I think we are done with lecture 1. So that is fundamentals of lecture 1. Before we end. I'd like us to write that particular program that was written, okay, in the whole this one that we saw. Okay, I think it goes like this: hashtag what? Include. Okay, if you remember, it says what? IO stream. By this, I should be able to write this particular thing, right? Because we've done it several times. If you remember, using what? Namespace std, like that. I think I missed something. Yes, and then remember that we write what? The function int main, and then we put the parentheses in here, and then we put what? Return 0 somewhere here. Yes, and then I think they wrote that C out, and then we write, okay, I can code C++ like that, and then they place for end line in here like that. So let's run and let's see. Yeah, so you say what? I can code. I hope you can see.
Yeah, I can see.
I can code C++. So I hope you can explain this code. If you have been asked, I hope you can explain this code, right?
Yeah.
Yeah, so that's great. That's great. And I guess we can continue. So
For more information and also to reach us, please contact the numbers on the screen. You can also reach us through our social media handles displayed on the screen. Please do like, follow, and subscribe to our social media handles. A Softek IT Consult. Innovative solutions with the difference.